Understanding bias in AI systems. Understanding bias in AI systems is a crucial aspect of ethical considerations in AI deployment. Bias in AI refers to the systematic and unfair discrimination in decision-making processes that can occur when AI systems are trained on data that reflects historical inequalities or societal prejudices. As AI systems increasingly influence critical aspects of human life, from hiring decisions to criminal justice, understanding and mitigating bias is paramount to ensuring fairness, accountability, and transparency. This lesson will explore actionable insights, practical tools, frameworks, and step-by-step applications that professionals can utilize to address bias in AI systems. One key insight is the importance of recognizing the sources of bias in AI systems. Bias can enter an AI system at various stages, including the data collection process, algorithmic design, and deployment. For instance, if an AI system is trained on datasets that are not representative of the population it will serve, the system may produce biased outcomes. This can be observed in facial recognition systems, which have been found to perform less accurately on individuals with darker skin tones due to training on predominantly light-skinned datasets. Understanding these sources of bias allows professionals to implement strategies to mitigate them, such as ensuring diverse and representative datasets and continuously monitoring and updating the AI models. To address bias effectively, one practical tool is the use of fairness-aware algorithms. These algorithms are designed to minimize or eliminate bias in AI systems by incorporating fairness constraints directly into the model training process. For example, the Fairness Constraints Framework allows developers to specify fairness criteria that the model must satisfy during training. By doing so, the algorithm can adjust its predictions to ensure equitable treatment across different demographic groups. Implementing fairness-aware algorithms requires a clear understanding of the specific fairness criteria relevant to the context, such as demographic parity or equalized odds, and the ability to balance these criteria with other performance metrics. Another critical framework is the AI Fairness 360 Toolkit developed by IBM, which provides a suite of metrics and algorithms to detect and mitigate bias in AI models. The toolkit offers a comprehensive set of tools to assess fairness throughout the AI lifecycle, from data pre-processing to post-deployment monitoring. For example, the toolkit includes pre-processing techniques, such as reweighting and resampling, to adjust the training data distribution, as well as in-processing techniques, such as adversarial debiasing, to modify the model's learning process to ensure fairness. By incorporating these tools into the AI development pipeline, professionals can systematically reduce bias and enhance the fairness of their AI systems. In addition to technical solutions, it is essential to adopt a holistic approach that includes organizational practices and policy interventions. Establishing a diverse and inclusive AI development team can help ensure that multiple perspectives are considered during the design and implementation of AI systems. This diversity can lead to the identification of potential biases that may not be apparent to a homogeneous group. Moreover, organizations should implement policies that promote transparency and accountability in AI decision-making processes. This includes documenting the data sources, algorithms, and decision criteria used in AI systems, as well as providing mechanisms for auditing and redress in cases of biased outcomes. Practical application of these strategies can be seen in the case study of a hiring AI system used by a leading tech company. The system was initially found to exhibit gender bias, favoring male candidates over female candidates for technical roles. To address this issue, the company implemented a multifaceted approach that included retraining the AI model on a more diverse dataset, incorporating fairness constraints into the algorithm, and establishing a cross-functional team to oversee the AI system's deployment. These efforts resulted in a significant reduction in bias, leading to more equitable hiring outcomes and increased trust in the AI system. Furthermore, professionals should be aware of the legal and ethical implications of deploying biased AI systems. In many jurisdictions, anti-discrimination laws prohibit the use of AI systems that result in disparate treatment or impact on protected groups. Therefore, Organizations must ensure compliance with these regulations by conducting regular audits and impact assessments of their AI systems. The European Union's General Data Protection Regulation, for example, mandates that organizations provide explanations for automated decisions and ensure that these decisions do not lead to discrimination. By aligning AI deployment with legal and ethical standards, professionals can mitigate the risk of bias and its associated consequences. In conclusion, understanding and addressing bias in AI systems is a complex but essential task for ensuring ethical AI deployment. By recognizing the sources of bias, utilizing fairness-aware algorithms and toolkits, adopting organizational practices that promote diversity and transparency, and complying with legal and ethical standards, professionals can significantly reduce bias in AI systems. As AI continues to permeate various aspects of society, these strategies will be crucial in building fair and equitable AI systems that benefit all individuals. Through ongoing education and collaboration, the AI community can continue to advance its understanding of bias and develop innovative solutions to create a fairer and more just society.